Hey guys, today we're doing 7-5 proportions in triangles. First we'll look at proportions with parallel lines in triangles. So we have this triangle JLN. If LN is 9.6, we want to find LM and MN. So we're going to start by first labeling what we need to find, which is X. As of right now, we don't really know anything about the similarity of these triangles. However, given that KM and JM are parallel as labeled by those arrows, we know that angle K, or angle LKM and angle LJN are congruent, and angle LMK and angle LNJ are congruent by corresponding angles postulate, if you remember that from our triangle proofs. So then we know that triangle JLN is actually similar to triangle KLM right there by angle-angle similarity. So because of that, we know that basically 3 over that total, which is 8, is equal to X over the total of 9.6. If we cross multiply, we get 8X equals 28.8. So X is 3.6. So because of that, LM, which is X, is 3.6. MN is 9.6 minus 3.6, which is 6. So 3.6 and 6. Okay, if we look here, if BD bisects AC and CE, we want to know if these are parallel here. So basically we need to see if 5 over the total of 10 is equal to 6 over the total of 12. And 5 over 10 equals 6 over 12, because they're both 1/2. So we're good there. We also know that angle C, which is in both triangles, is congruent to angle C. So then triangle BCD is similar to triangle ACE by SAS similarity. So because of that, we know that CBE and CAD are congruent because they're similar triangles, and that's what we know about similar triangles. And CDE and CEA are also congruent. So then, by corresponding angles postulate, BD must be parallel to AE, because this angle and this angle are corresponding, this angle and this angle are corresponding. So we essentially just figured out these two theorems, one being the side splitter theorem, which says that if we have these two parallel lines in the triangle like this, where one is the base and one is somewhere in between, we end up with proportional sides. Triangle midsegment theorem shows that if this segment in the middle cuts each side in half, each of these sides, then we know that this segment here will be half the distance of this one. Please don't worry about the names of these. I will never ask you that. Just know how to use them. So if we go to the side splitter theorem, if we're looking for the value of X in PQR, if we're looking for X, we're really looking for the big triangle, and then we're going to split it right here where Z is. Okay, so we're not going to worry about Y. So then this section right here will be 16. This one right here will be 12. So then since we have these parallel lines, what we know is that X plus 2 over 16 is equal to X over 12. If we cross multiply, we get 16X equals 12 times X plus 2, and that is equal to, so we have 16X equals 12 times X, which is 12X, plus 12 times 2, which is 24. We subtract 12X from both sides, we get 4X equals 24, so X equals 6. I'm going to switch colors for the next one, just so it's a little easier to look at. I am going to redraw the triangle, only one, not three like in 7-4. That was a lot, only one. So we're going to draw the big one, which is PQR. And since we're trying to find Y, we'll just draw UV. So then that's Y. QV is 9. QU is 12. We know PR is 30. And then since we already know X is 6, PU right here will be X plus 2, which is 6 plus 2, plus another 4, which is 12. And then VR over here will be X, which is 6, plus 3, which is 9. So now what we have is 12 and 12 and 9 and 9. So we can use the triangle midsegment theorem, which told us that whatever this is, this will be half of it. So Y will be 1/2 of 30, which is 15. Okay, one more with this triangle. Switch to red. So now, draw the big one again. P, Q, R, but we're looking for Z. So we'll draw ST again, and then these were parallel. And then this is 30. This is Z. TR right here is actually 6 because it was just X. And then PS was X plus 2, so 6 plus 2, which is 8. And then SQ was 16. QT was 12. So we have a couple options here. Now what we're doing is comparing basically this triangle and this triangle, and also using the side splitter theorem. So we know that basically 16 over 24 will be equal to 12 over that total of 18, which is equal to, so now what we really want to compare, we'll do triangles, I guess, Z over 30. So that's all three. Technically, we only need one of them. So we'll use 12 over 18, but we could use either. We do 18Z equals 12 times 30, which is 360. Divide by 18 on both sides. We're going to end up with Z equals 20. Okay, done with that example, finally. We have a corollary to the side splitter theorem. Don't worry at all about but we know that if 3 parallel lines intersect 2 transversals, the segments intercepted are proportional, so we have more proportional sides. Okay, so now we are going to use that corollary to the side splitter theorem, which again, we'll never need to know the name of. Basically what we have is a reflecting pool with parallel walkways, so these walkways in between are parallel, and we need to find, if they're going to put tiling around, what X is. So really what we have is just proportional sides, just like up here, proportional, 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 proportional. We know X over 60 is going to be equal to 24 over 72. Cross multiply, 72X equals 1440. Divide, X is going to be 28. Please pause the video right here and try this one, and then come back and check. Okay, so if we have AD is 9, BD is 12, BE is 16, we want CE. Well, because of that corollary, 12 over 9 is going to equal 16 over X. Cross multiply, 12X equals 144. Divide by 12, so X equals 12. Okay, so these next couple examples we are going to skip. This theorem basically shows us that if a ray here bisects the angles, what we end up with here is this side is proportional to this side, and this one's proportional to to this side. So I'll show you some examples for that. So using that theorem. So what we have here for this first one, so basically we want AD and DC. So AD is x. If this whole thing AC is 13, this will be 13 minus whatever x is. So then we're able to set up 13x over x, or I'm sorry, 13 minus x over x equals 16 over 10. When we cross multiply here, we end up with 10 times 13 minus x equals 16x. So 10 times 13 is 130. 10 times negative x, negative 10x equals 16x. If we add 10x to both sides, we'll get 130 equals 26x. So x is equal to 5. So if x is 5, we know AD will be 5. CD will be 13 minus 5, which is 8. Okay. Please pause and do these next two on your own, and then we'll come right back. I'll be here the whole time, but you'll come back. So number 2, we can compare 3x minus 7 to 12, and 3x minus plus 3 to 18. So 3x minus 7 over 12 equals 3x plus 3 over 18. If we cross multiply, we have 12 times 3x plus 3 equals 18 times 3x minus 7. 12 times 3x, 36x. 12 times 3, 36. 18 times 3x, 54x. 18 times negative 7 is negative 126. Okay, so now if we subtract 36x on both sides, 18x minus 126 equals 36. If we add 126, 162 equals 18x. Divide by 18 on both sides, and x ends up being 9. So that was part of it. Kind of moved down into the number 3 spot, but x equals 9. And if x equals 9, then GH, 3x minus 7, so it's 3 times 9 minus 7, which is 27 minus 7, which is 20. I'm sorry, that was GK, wasn't it? That was GK, will be 20. GH will actually be 3 times 9 plus 3, which is 30. Number 3, try on your own. However, I will tell you the answer so you can check your work. You should get x equals 12.25. All right, these are the 3 major theorems we did. Again, you don't need to know the names. I will never quiz you on the names, but you'll have to be able to use them. All right, guys, have a great day. Thanks.